But here's the answer. We start with the thin lens equation. You might be tempted to solve for 1 over O to figure out what's going on with O. But is that right? No. You want to know how do we make I less than 0. So we isolate that. 1 over I is 1 over F minus 1 over O. Then we ask for I to be less than 0, this whole left side has to be less than 0, which means that 1 over O is greater than 1 over F, right? That'll do it. And so what does that mean about O and F? O is greater than or less than F? Less than, right? The smaller O is, the bigger this 1 over O is. F is fixed. So we need O less than F. So the object must be a distance less than F from the lens. O has to be less than F. C is the correct answer. We had a kind of an even split last time. Well, about a third of you got it. And that's the reasoning behind that. Now let's think about taking a lens and looking at very distant objects. So we have O a lot greater than F. Where does the image end up? Well, going back to the thin lens equation, we have 1 over I plus 1 over O equals 1 over F, right? And so if the object is at infinity, this just goes away. And so 1 over I equals 1 over F, so I is approximately equal to F, which is to say that the image is very close to the focal length. And that's how cameras work. When you set a lens to infinity, if you've ever worked with a lens that you can dial it and set the focal length, when you set it to infinity, it's basically projecting the image onto a plane which is a distance f of the focal length from the lens. Okay? Now, if objects are slightly closer, then you have to adjust the distance of the lens to the focal plane, or to the image plane, the sensor plane. Nowadays, we don't have film in cameras really anymore, so we say that the image is on the camera sensor here. So that's for O a lot greater than F. We can turn this around as well, right? And say, what if we have the object at the focus, or approximately equal to the focus? In this case, suppose we have an object like the very bright LED screen inside the projector up there. It's just a few centimeters away from the lens in the front of the projector. And it's casting this much larger image. The magnification of that, what you're looking at here is an image of a tiny little LED screen, right? There's not a 8-foot by 10-foot thing inside the projector. So you're taking a very small, very bright thing and making an image of it that is at the screen here. And to do that, you have the image going to pretty close to infinity, or a very large number. All right, now you still have a focus adjustment on a projector, but that's how a projector works. Because the screen is not infinitely far away from the lens. It's, 15 or 20 meters away from the lens. Whereas the object is very close to being at the focal length of the lens away from the lens. So lastly, I'd like to talk a little bit about optometry. Some of you may end up being optometrists or ophthalmologists yourselves. The eye, it's an amazing thing, has an image. Well, it's not a plane. It's sort of wrapped around in a spherical shape, but most of the action is occurring right in the center of it, where most of the nerve cells are in your eye, the fovea of your eye, on your retina. But you do have cells going out to quite a large distance, allowing your eye to see I think even almost greater than 180 degrees in front of you. But like I say, most of the images that you're going to be concerned about are cast onto the back of your retina right there. Now, your eye can change the focal length of the lens. The muscles attached to the lens pull on it to stretch it out and change the focal length of the lens by a little bit. Now, as you get older, various things happen. You can get presbyopia, and when you hit about 40 years old, almost all of you will start getting presbyopia, which means that you're unable to focus on nearby things very well. Okay? Looking around, I see maybe about a quarter of you. I don't know how many people wear contact lenses, but that's about the right number. About a quarter of people have myopia from a young age, which means you have overly curved corneas, or there can be other conditions that cause myopia, and that can be corrected by placing lenses in front of the eyes. Okay, so you have presbyopia, hyperopia, and myopia. And if you're like me, you have myopia and presbyopia at the same time. Okay? So in fact, without my glasses on, I can only focus between about here and here. That's my depth. I can't imagine how people survived in the old days before lenses, being only able to see stuff that was exactly 18 inches away or something like that. So I have glasses that correct for nearsightedness, meaning myopia, allowing me to see distant objects at the top, and then the curvature of the lenses changes as you go toward the bottom of the lens to be correcting for myopia. These are so-called progressive lenses. And they're very nice, but they make things look a little weird and distorted. Anyway, you'll be doing actual calculations of the same kind that optometrists do to calculate what focal length lens do you need in front of your eyes to do various corrections, and where do the images of those lenses appear in front of you. So have a good week, and I'll see you next week.